Hey guys, welcome back. This is That Math Guy. So as always, I've got the YouTube and the email address up top for any comments, questions, suggestions. Today's kind of a quick one, just some divisibility rules, integer divisibility rules and shortcuts. We're really trying to figure out how we can tell if a number, specifically an integer, is divisible by numbers up to 10 or by integers up to 10 without actually performing the operation, without doing the division or going to the calculator. So divisible just meaning, okay, this number will divide evenly with no remainder, with nothing left over, no decimal, no remainder, no nothing like that. So diving right in, kind of check on the rules. Zero is a quick one. No number is divisible by zero. If you try to divide by zero, it's understood to be undefined. You cannot divide into zero groups of anything. You think of division as, let's say 6 divided by 3 is 2. We're taking 6 items and dividing them into 3 groups. We have 2 in each group. You cannot divide into 0 groups. You can subtract everything away, but you cannot divide and end up divide into 0 groups. It just doesn't work that way. So that's why it's understood to be undefined. Just a quick one there. You cannot divide by 0. 1, we're talking about integers. Every integer is divisible by 1. Simple as that. No trick needed. Doesn't matter what you're trying to do. 7 divided by 1 is itself. 13 divided by 1 is itself. 26 over 1 is itself. Does not matter. Everything will divide evenly by 1. We're talking about integers. You count by ones, you're going to get an equal, even number every time, or an even divisibility. Here's where we start trying to go into these, and you'll notice that I've actually I've colored some of these. So if you notice as we scroll through, the similar colored tricks are similar. So for 2, if the number we have is even, it will divide by 2. It's divisible by 2. So in other words, if it ends in 0, 2, 4, 6, or 8. So if you think about it, you're counting by 2s. 2, 4, 6, 8, 10, 12, 14, and onward. They're all going to end in either 0, 2, 4, 6, or 8. So that's an easy one. If it is divisible, or if it is even, it is divisible by 2. So as long as it ends in a 0, 2, 4, 6, or 8. So you can go ahead and try those out. Again, 14 divided by 2, 7. Simple as that. Okay. 100 divided by 2 is 50. Try any one of those. It'll work out. It's an even number. It's divisible by 2. Moving right along. 3, if the sum of the number's digits is divisible by 3. Now, sum means if I add them all up. Okay, it's the result of addition. So if the sum of the number's digits is divisible by 3, then the whole number is divisible by 3. So just a couple of examples there. So let's start with 1. 27. We know that 27 divided by 3 equals 9. That's great. Okay, so 27, let's do 2 plus 7. That gets me 9. So the question is 9 divisible by 3? Yes, it is. So it'll always come out to be a smaller, more manageable number, and so it's easier to check. Okay, let's try another one. Let's try 134. Okay, well, 1 plus 3 plus 4, what does that equal? 8. So it's really quick to say, all right, is 8 divisible by 3? No, it is not. Okay, pretty simple. So it's really cool that we can take a really large number, just add the digits up and see if that number is divisible by 3. Pretty simple. Moving on to 4. If the last 2 digits of the number make up a number that is divisible by 4. Okay, the reason for that is because once we get to beyond 2 digits, we're into the hundreds, the thousands, the 10,000s, the 100,000s, all that stuff. So the last 2 digits of the number are the only ones that we have to actually check to see if it's divisible by 4, because 100, or any multiple of 100, we already know is divisible by 4. So 100 divided by 4 is 25 with no remainder. So any number of 100s is going to be divisible by 4. So we only have to check the last 2 digits. So, for example, 108. Okay, we just look at the 8. That is divisible by 4. 3,640. Okay, we're just looking at 40, the last 2 digits. Okay, And 40 is divisible by 4, so we know the entire number is. Okay? 9,674,226. Doesn't matter. You're just looking at the last two digits. Is 26 divisible by 4? It's a little smaller, a little easier to deal with. I know off the top that it's not. Okay, because if you think about it, 24 is divisible by 4, and then it's only 2 more, so we can't fit another 4 in there evenly. All right, all kinds of little tricks and ways to make sense of it. Okay, scrolling down, number 5, you'll notice it's green just like 2 because it's got a similar rule. We're just looking at what the number ends in. So for 2, I'm sorry, remember it was if the number ends in 0, 2, 4, 6, or 8, if it's even in other words. For 5, fewer numbers, digits that the number can end in. If the number ends in 0 or 5, then it is divisible by 5. So in other words, we'll think about, how we count by 5s. 5, 10, 15, 20, 25, 30. They alternate between ending in 5 and ending in 0. So really all you got to do is check the number, see if it has a 0 or 5 at the end. So 426. It ends in a 6. Nope. Just looking at the last digit. Okay. 325 ends in a 5. Yep, simple as that. If it ends in a 0 or if it ends in a 5. For 6, I left it non-color coded here because it doesn't really have the exact same rule as another one. It is a combination of 2 rules before it though. 6, if a number is divisible by both 2 and 3, then the number is divisible by 6 as well. Think about it, 2, because it has to be even, because, if you keep counting by 6s, 6, 12, 18, 24, 30, you notice all of those numbers are even. So that means they're all divisible by 2. Okay, so every number that will divide by 6 will also divide by 2. And then they also have to be divisible by 3, because if you think about it, every group of 6 is just 2 groups of 3. So if it works for both 2 and 3, it's going to work for 6. So all we got to do is check the number. Okay. Does it end in a 2, 4, 6, 8, or 0? Yes. And then is it divisible by 3? Well, 4 plus 8 equals 12. Will that divide by 3? Yes, it will. So 48 is divisible by 6. Okay, another example. I'm just making this up off the top of my head. 3,942. Okay, I didn't want to do an odd number because obviously it wouldn't be divisible by 2 right off the bat. So we'll go with an even number. So obviously we know this divides by 2. We just have to see if it will divide by 3. So 3 plus 9 plus 4 plus 2. If you can add that all up at one time, great. If you just want to do it in groups, that's fine. 12 plus 6. What does that come out to? 18. Will 18 divide by 3? Well, we can add the digits up. 1 plus 8 equals 9, or you might have just known right off the bat 18 divides by 3. Either way, we can see it divides by 3. So those are 2 examples that divide by both 2 and 3. So if it's odd, automatically we know it's not divisible by 6. And then if the digits don't add up to something that divides evenly by 3, it's not divisible by 6. Okay, I'll do one more example just since we're talking about it. I've done non-examples for the others. 362. Okay, well, obviously it divides by 2 because it's even. But does it divide by 3? Well, 3 plus 6 plus 2 is 9 plus 2, which is 11. So it does not divide by 3. So this one will not divide by 6. Doesn't work. Okay. Now, 7. I don't really like 7. It's kind of long, kind of involved, but it works. I just generally haven't taught this one, or I just say go to the calculator. It's a little bit easier. But there's a trick, so we'll show you. What you do is remove the last digit from the number and double it, then subtract that from the remaining part of the number before after you pulled that digit off. If the result will divide by 7, the original number will divide by 7. Okay, so I'll just do a quick, easy one right here. 217. Okay, we're going to divide this up into 2, 1, and then the 7 comes off. Okay, what we do is we double that 7, make it into 14, and then we just subtract it from the remaining part of the first part of the number. And then we check. All right, well, 21 minus 14 is 7. Will 7 divide by 7? Well, yes, it will. So 217 will divide evenly by 7. Okay? So we'll try one more. All right, we'll try a couple more. 658. Okay, same kind of thing. Okay, we're going to take that last digit off. I like to just separate them. And then I'm going to double that 8 and make it into a 16. And then all we got to do is subtract 65 minus 16. We get 49. I know for a fact 49 will divide by 7. So there we go. That'll work. All right. And we'll try another one. Last one. Okay, 474. So same idea. 47 to start off. That 4 gets separated off. We're going to double the 4, make it an 8, and subtract it. 47 minus 8 equals 39. 39 will not divide evenly by 7. So 474 is not divisible by 7. Okay. Last couple right here. 8, it's similar to 4. You notice I did it both in red. It's the last 3 digits of a number, though, instead of the last 2 digits of a number. Okay? Because once we get past the 3 digits, we're into the thousands place, 10,000s place, and beyond. 1,000 will divide evenly by 8. If you do 1,000 divided by 8, you're going to get 125. So it's really just the hundreds place and beyond that we have to pay attention to. Okay? It's really all we got to do. So, it doesn't matter how long the number is. We just look at the last 3 digits. So 9,496. I don't know. I'm just making this number up off the top of my head. Okay, and this one can be a little bit tricky just because you're looking at some larger numbers. Okay, all we got to do is look at the 496, and we got to say, all right, does 496 divide evenly by 8? You might not know that off the top of your head. This is kind of where it becomes a little bit more of a cumbersome one, but this one does, so it works out. Okay. So one last one. 2892. Okay, and again, there's some of these you're noticing. You may or may not be noticing that I'm doing even numbers every time because obviously every even number is going to have an even multiple. So if it's odd, it's just automatically out. But 2892. We're just looking at the 892. Okay, does 892 divide by 8? And if you're not sure, well, we know that 800 obviously would, so you can just look at the 92 if you wanted to. But 892 divided by 8 is not going to work out. Okay, so that whole number is unfortunately not divisible by 8. If you wanted to know, 892 comes out to divided by 8 comes out to 111.5. Okay, last couple examples. I'm going to breeze through them because I'm running out of time. 9 is the exact same rule as 3, except the digits have to divide by 9. So that's really it. Okay, so we'll do an easy one. 36. 3 plus 6 equals 9. That will divide by 9. Okay, pretty simple. Larger number, 558. 5 plus 5 plus 8 is 18. 18 will divide by 9. Okay. 284. 2 plus 8 plus 4. It's going to be 10 plus 4 is 14. Will not divide by 9, so that doesn't work. And then the last rule, again, it's one of the ones where we're looking at the ending numbers. 10. If the number ends in 0. 10, 20, 30. All of them are going to end in 0. I shouldn't even have to do any examples of that one because that's really, really easy. So if the number ends in 0, it will divide by 10. Guys, these are great rules when we're talking about simplifying roots and doing radicals. It's just good to know what divides by what. I mean, it's one of those things that's going to make your life a whole lot simpler. So hopefully that helped, and feel free to reach out if you want me to expand on anything. Thanks.